Hi, and welcome back to the channel. In today's lesson, we're going to be taking a look at this scientist called Neils Bohr, and we're going to be looking at what it was that he discovered. Now, Bohr made some really important discoveries, which led us to understand how the electrons are arranged outside the nucleus of an atom. Before we jump into Bohr himself and who he was and where he was from, that kind of stuff, we need to just take a look at a quick little bit of science. So here we're going to look at, if you look into the sky on a rainy day, sometimes you will see a band of colors. And the reason why this happens is this. Here is a diagram we're drawn here. This is the sun. Okay, and the sun gives off light. I'm going to draw it with a black line here, but it's important to know that obviously the light that comes from the sun isn't colored black. We call this white light. The reason we call it white light is because essentially it's white. It's a mixture, but it's a mixture of lots of different colors of light. And when they blend together, they appear to be white. So the reason why sometimes we see when it's raining, we see this band of colors is because the white light hits droplets of water. So this is a raindrop. And when the white light hits the raindrop, the light bends, okay? So it bends very slightly. But the different colors in the light bend by different amounts. And it turns out that the blue light bends by the most, okay? It bends the most. So as you can see here, this is the biggest angle, if you like, okay? So the blue light bends the most. Maybe the green light bends also, but not quite as much. Sorry. And finally, the red light, this bends by the least. The reds and the oranges and the yellows. This bends too, but it bends by the least. And the result is that we get this band of colors in the sky. Here's the red. Here is the green, which is below that because it's bent more. So it bends more. And here at the bottom is the blue. Now, of course, there are other colors in this, and hopefully you're recognizing what I'm drawing here. Essentially, I'm drawing a rainbow. So the everyday name for this creation in the sky, this band of different colors, is called a rainbow. Now, obviously, there are other colors in here, and there are many, many different shades. We'll probably learned about 7 colors: red, orange, yellow, blue, indigo, sorry, green, blue, indigo, and violet. We learn of 7 colors, but really there's way, way, way more colors than that are like shades in between those colors. But there are 7 main bands, if you like. So within the red, there's lots of different shades of red. Within the yellow, there's lots of different shades of yellow, and so on. We call this a rainbow, but there is a kind of a more sciencey name for this thing. We call this thing a spectrum. Okay, so I spell it like this. Sorry, my pen has stopped working. Yeah, we call this a spectrum. So S-P-E-C-T-R-U-M, a spectrum. So a spectrum is basically just this band of different colors. Yeah, anyways, my pen has stopped working. So I'm going to go over here and we're going to read it over here. Okay, so as you can see, the band is formed when white light from the sun passes through raindrops, bending the different waves, making up the light by different amounts. We call the band of colors produced a rainbow, but the scientific name for this is a spectrum. A rainbow is an example of a continuous spectrum. And the reason why we say it's continuous is because it has all colors with no gaps. Okay, so here's what it looks like. This is a rainbow on the right here. The picture on the right shows a typical rainbow. But the picture on the left here shows what we would call a spectrum. It's the same thing, but it's done using scientific equipment, and it doesn't have the bow shape, if you like. It's just got the spectrum, the different colors. This is white light, and it has been split up. Continuous spectra can be produced artificially by passing light from a white source through a prism. And a prism is just a pyramid or triangle-shaped piece of glass. So essentially, in nature, raindrops act as prisms, and that's what produces for us rainbows. All right, so pause the video and have a go at them 3 questions for me now. All right, so you should only be watching the video if you've tried them 3 questions. If for people in my class, you know where these questions are, they're in the booklet. And again, it's really important that you do the practice here. Otherwise, you don't get a chance to practice what you've learned. Right, what is a spectrum? Okay, so hopefully you've said that a spectrum is a band of colors produced when light passes through a prism. That's what a spectrum is. So it's a band of a continuous band of colors, or a band of colors produced when light passes through its spectrum. What is a prism? That would be a pyramid or triangular shaped piece of glass. And finally, describe a continuous spectrum. So continuous spectrum is all the colors of a spectrum with no gaps. Okay, that's why we call it continuous. So it's a black, as you can see, there's a black background, and we've got bands of all colors and no gaps. That's really important, no gaps. That's a continuous spectrum. So now we can jump into Niels Bohr. Who was he? Okay, well, most of what we know about the electrons in an atom, how they're arranged, comes from Niels Bohr's study of spectra. Niels Bohr was Danish. He was a Danish physicist, and he investigated the light given off by different elements when they were burned. So Bohr wasn't studying the light from the sun like this. So that's white light. Bohr instead was taking samples of elements. So he might, and the element he mostly worked with was the element hydrogen. So we took hydrogen gas, okay, and he burned the hydrogen gas, okay. So he put a flame under it and he burned a piece of hydrogen. And obviously when you burned it, it gave off light, okay, gave off light. And this is light off the hydrogen. And what he did was he passed it through this triangular shaped piece of glass called a prism. So he was using a prism, not a raindrop, okay? He passed the light through the prism, and it obviously bent the same way as we saw before. But this time, it didn't have all the colors, okay? So it only had specific colors. It didn't have all the colors like the white light did, because it was light given off by hydrogen. And mostly what he saw was red light, okay? And he produced a different type of spectrum. This was a spectrum that was pretty much all black, like this. It was a black background, and it only had specific bands of color. So instead of being continuous with all the colors, it had a little band of red here, and the rest was all dark. And of course, if it's dark, that means there's no light at all there. So darkness means an absence of light. Okay, so this was a black background with bands of color in specific places. So this is a different type of spectrum. This is not a continuous spectrum because it's not continuous. It has gaps. Sometimes it might have another band of color. It might have a band of blue, and the blue might be up here somewhere. It might have a band of blue up here, and the rest will be black. So we don't call this a continuous spectra. This instead is called an emission spectrum. This is an emission spectrum. Why? Because it came from light that was emitted from elements. So it was emitted light. So this was an emission spectrum, not a continuous spectrum like a rainbow, an emission spectrum. And how would we describe this? We would say it's a black background. Black background with bands of specific colors. Okay, with bands of specific colors. So this is what Bohr was studying, okay? And he discovered the emission spectrum. Let's go back and read a little bit more here. So he was a Danish scientist who investigated the light given off by different elements when they were burned. The main element he studied was hydrogen. He passed light from burning hydrogen through a prism, and the spectrum was produced. The spectrum was not continuous like a rainbow. Rather, it contained only some narrowed colored lines on a black background. Because Bohr was studying light emitted from different elements when burned, he called this type of spectra the emission spectra. So there it is, emission spectra. As equipment advanced, two pieces of equipment became important for Bohr's studies. One of these was called a spectroscope, and the other one was called a spectrometer. Okay, so very similar words, spectroscope, spectrometer. What's the difference between these two things? Well, scope, this word just means look. So this equipment, a spectroscope, was just used for looking at spectra, basically. Spectrum, sorry, and to look. So spectroscope, to look at the spectrum. So in a spectroscope, you could produce something like this. You could actually just see the different spectra. Okay, so as you can see, here are 5 different emission spectra. And obviously, each of these belongs to a, well, not obviously, but each of these belongs to a different element. Okay, I'm going to see more about that later on. But yeah, each of those is a spectrum, is an emission spectrum. And with a spectroscope, we can just look at that. What then is a spectrometer? Okay, well, again, spectral refers to spectrum. And the spectrometer, the meter bit, refers to measurement. Whenever we have a meter or something like a meter stick, it's for measuring. So this was for measuring spectra. Now, what do we mean by measuring? Well, a spectrometer, a spectrometer, was actually able to measure the specific frequencies of light. So each band here represents a certain frequency of light. So we could just call this purple. See this one up here? This is purple. But this one here is also purple. And they're not the very same. So just having words like purple isn't very useful here. It's better to know exactly the frequency of light that we're looking at. They're both very similar purples. It's the same here. Here are 4 similar reds, but they're not all the exact same red. You know, it's not the exact same color. So it helps if we can measure this specific frequency of light. Again, take a closer look at this later, but know the difference between those 2 tools and their abilities. Okay, so as you can see there, the difference between spectroscope, spectrometer. I have it summarized here and here. Okay, so again, I want to pause the video and do these questions, and we will correct them in class the next day. All right, we'll see you then, guys. Take care. Make sure you do the questions, please.